This video is about using some of the other software on the Fox in a Box version 3 image. The Fox in the Box project is by Burns Fisher, WB1FJ, and Chris Thompson, G0KLA AC2CZ. And I'm Alan Johnson, KU2Y, AMSAT's Vice President for Educational Relations. So in another video, we explained how to get Fox in a Box up and running for receiving and decoding telemetry from AMSAT's CubeSats on orbit. This video is about using some of the other software. So let's take a look at what's on here. So one thing is it has tracking software. It's got actually two trackers, gpredict and G0KLA tracker. So let's run gpredict first here. So we have a bunch of AMSAT and other amateur radio satellites pre-programmed in here. So the default location, if you haven't set it or done anything else, will just be basically Washington, DC. So you see it there on the East Coast. And I can also run the KLA tracker here, which is a nice minimalistic view here down the bottom, showing the this moves over time and gives you the peaks for when the various satellites are coming over. And gpredict has a lot of different features in terms of tracking and the like, you can explore that. Now, if we want to change the location, we can double click on this Set My Location icon, and we can choose what method of setting the location. So, for example, I could set it using my grid square. So I don't know, let's just put in FM30 as my grid square. Oh, it's got to be a 6-digit grid square. So I'll put AA in there. Okay, and it's converted that grid square into a latitude and longitude. And it's asking for the location. I actually don't know where that is. So I'm just going to call it my location. And my altitude in meters has to be an integer. Okay. So now if I run gpredict here, oops, looks like I picked somewhere in the middle of the ocean there. But there it is, there's the location being set. So some of the other software that is on this, we can run the WebSDR. So this is a WebSDR known as OpenWebRX. And we're going to access that using the browser. And you can also, if you have another browser on the same network, then you can actually access, multiple people can actually access the WebSDR at the same time. So here it is. So this is our waterfall, and we can set different profiles here. This one is set up for the CubeSat simulator. But if we choose, for example, we choose this weather band, there typically are weather band NOAA weather radio if you're in the United States, and we can, for example, click on one of these, and we can listen to it, especially if I turn on my audio here. Actually, I don't have audio, but this is you can click around different bands and listen to things. If I set it to the 2-meter band here, and if I click on packet here, the WebSDR actually automatically decodes APRS packets. So when we see a packet in a minute or two, as we hopefully will, we should, there we go, we just got a packet there, and you see it's decoded. There we go. This one here has coordinates on it, and if I click on it, it's actually going to pull up a map here, and it's going to plot. Now it thinks my ground station is here in the middle of the ocean, Normally, you would set that to where you're located. But the software will basically automatically plot the APRS stations that you receive. And there's all different modes. You can also listen to, for example, FM radio. Switch to wideband FM, and you can listen to stations that way. So that is the built-in WebSDR. There's another SDR known as CubicSDR, and I will run that. Now, when we first run this application, we have to select the input, and I'd recommend if you have an RTL SDR, it's going to be the RTL 2838U device there. So here it comes up. Now I actually have a FunCube and 2838. We could pick out either of them. I'm going to pick the RTL SDR and say start. And so there it is. So CubicSDR, it's a full-featured SDR, different modulations. You can tune around different things, all kinds of things that you can do with that. This one will tune the APRS packets that are coming in. So that is CubicSDR. Now you can also, this image also has QSSTV, which automatically decodes SSTV images. You can select either the ISS if the ISS is currently doing a SSTV event. If you have a CubeSat sim, you can select that. You can choose some other frequency, or this one you can test it out with just a recorded WAV file. So that's what I'm going to do, since there's no activity right now. So this is the QSSTV application, and you see by the waterfall here and the signal that it's actually playing this pre-recorded WAV file, and it's decoding it here. The format is actually Scotty2 is the format that this recording is in, which is the same format that the CubeSat simulator uses. QSSTV will actually automatically do it because, for example, the ISS typically does PD120 format. Okay, so that's just a AMSAT logo there. So I will quit. We can also do run Direwolf and do packet decoding. And you see all these different options here. You can set the US APRS frequency if you have a CubeSat sim in APRS mode. Other countries. You can also go for APRS on the ISS. And you can also test it too. So I'm gonna select the US one here because we saw before we were getting packets. So we should get a packet. So Direwolf is now running, and when we get a packet here, it should auto decode for us. Now there's another way of accessing packet decoding too, which is this icon here, and it actually runs CubicSDR, and then it takes the audio from CubicSDR and it sends it to Direwolf. So you can actually tune it a bit, and you can also see the spectrum as well. Okay, APRS is quiet for the minute here. I heard a packet there, it just wasn't quite. There we go, finally got one. So yeah, that's K3TU, that's Temple University here in Philadelphia. They have a very powerful digipeater. Okay, so I'm going to run the CubicSDR packet decoding. And again, I'm going to choose the US APRS. Now, there's a few steps here to manually configure CubicSDR. So once you're familiar with CubicSDR, you can use this. Basically, the instructions say, first we need to select our SDR, which is probably the RTL SDR, then click Start. So that's the first thing I want to do here. Click Start. And now the the instructions say I need to go under File, Session, Open Session, and then select the APRS Direwolf profile. So let me do that. Go under File, Session, Open Session, and now I need to go to the CubeSat Sim directory, ground station, CubicSDR, and this one here, CubicSDR APRS Direwolf. These other ones are for other frequencies in the options. So I select that. So now I'm tuned to 144.39 for APRS. I go back to my instructions here and I click OK. And now Direwolf is started. And so if everything works okay, we should see the packet, and then we should get the decode. There we go. And that is working. So the nice thing is here we can see the waterfall, and then we can see the packet getting decoded. The only downside to this is that you can't hear the packet, and that's because the audio is sent directly to Direwolf. If you use the other profile, you can hear the packet on the Raspberry Pi speakers. Okay. So there's one other piece of built-in software, and that's RTL TCP, and that lets you access remotely the RTL SDR dongle that's plugged in on the network. And also, we also have the PackSat ground station as well, although it's not configured. You'll need to configure that yourself. And then finally, we can also take a look at the Fox2Lem download profile here. I covered the Fox2Lem Fox in a Box profile in another video. So, but if I click on this download profile, you see it's got, wow, I don't know how many payloads that is. That's 7 million payloads that are stored. And if you click on individual satellites, for example, AO85, Fox 1A, you can see there's 961,000 payloads. And you go through the other, and there's lots there. Fox 1E, Husky, and in the future, we'll have some for Golf T. And what you can do is you can look at the data, and you can graph them, and you can also change when you looked at it. So you can choose particular dates and times, and look at what happened. You can also put in lots of historical data there, looking at temperatures. So we don't recommend using this profile for actually receiving telemetry, but it's great for reviewing things. All right, and then the one other thing I'll point out is that you can also access many of these through these Raspberry Pi menu options. You can also access the Arduino IDE. There is also a built-in soft keyboard here, so you can actually operate it just with a mouse without plugging in a USB keyboard. You can set various preferences and all the rest of these. And of course, you should always safely shut down your Raspberry Pi using the shutdown. So hopefully you have fun using all the additional software that is in the Fox in the Box version 3 image.